So, hello and welcome to everyone. I'm Poonam Thakur. I'm assistant professor at IIT Kanpur. And as you know, Mind Gala is the outreach initiative funded by India Biosciences. And under this outreach initiative, we have been running several of activities, including this Bheja Fry webinar series. So we invite some of the experts in the topics, but they will talk to you in a way that is accessible to all and the beginners in the field. So today we are joined by Dr. Arjun Ramakrishnan. He is assistant professor at IIT Kanpur, and he has done his Ph.D. from NBRC Gurgaon. So, that's one of the only dedicated brain research institutes within the country. Post his Ph.D., he has gone to two postdoctoral fellowships, one in Duke University and another one at University of Pennsylvania before returning to IIT Kanpur. And he does a lot of interesting work on aspects of neuroscience, including decision making, that he's going to talk to us about. So we are very thankful to you, Dr. Arjun, for accepting our invitation. And over to you now.
Awesome. Thank you so much for the kind introduction. I'm really, really happy to be here and talking about all the things that I'm interested in as well. And hopefully, stimulate an interesting discussion by the end of the talk today. There are going to be a bunch of questions that I'm going to pose for you guys in between through polls. Feel free to, access them, attend those polls, tell what you're thinking, because that is going to be the fun part of engaging with you guys. So let me know how you're thinking, because we all want to know how you make decisions, how biased we all are, right? Okay, so I'm going to start sharing my screen and get going with the presentation. I've also, as per the instructions for today's talk, kept the talk extremely accessible. So at times you might find things, you might come across things that you already know, and you can always let me know that if you want me to go faster, I can go faster. There are also aspects of the talk that are more state of the art, so feel free to stop me and ask me questions on that as well. With that, I'll get started. We've got a few slides to go, a few slides to cover down the line today. So let's do that now. So Poonam, if you don't mind, can you post the first poll question in the chat message? And by the time I reach there, I would really like to know what people are thinking. Okay, so you guys take the survey and answer the questions, and we will go about that as we cross the bridge. Okay, decision making and the brain, a Bheja Fry perspective. That's what we're going to talk about today. So what is today's talk all about? We're going to talk about what makes a good decision. So that's where we will start. All of us are curious what makes good decisions. Then we'll talk about a formal approach to it, different theories that talk about decision making, so on and so forth. I'll introduce a little bit of neuroscience, talk about what we know from the neuroscience perspective, and in the end, touch upon one aspect or one project that we have ongoing in the lab, something that will tell us why we are interested in all this in the first place. That's the outline for today. Okay, so if you have the poll, if you started answering the question, here's what the poll is all about. What makes a good decision, right? There are a couple of questions posed over there. So answer them. I don't think I'll have time to wait to check your answers, so I'll reveal your answers towards the end of the talk. But try and answer it before I show you the results in the next slide. So I'll give you like a couple of seconds for that. This is a lot more fun than the class because I can wait until they all give me the answers. But in this case, we'll have to sacrifice some things in the interest of time. So what makes a good decision? What makes a bad decision? The question that has been posed to all of you, just in case you haven't really seen it still, is think about a couple of good decisions that you've made in the past year and rate them against all the decisions that you've ever made, right? In terms of relevance, in terms of importance. And tell us why, what made those decisions good according to you. Similarly, with the bad decisions as well. Okay, this is actually an experiment that Yates and his colleagues carried out in 2003. And remarkably, each time I administer this in the class, the answers are almost always the same. When you look at them split into these two conditions, for example, if you look at the quality of the decision, where you might have rated on a scale of -5 to +5, or the importance on a scale of 0 and 10, you might see, and eventually later, like I'll actually show you readings from the class that I last taught, that people invariably rate the quality of good decisions to be better in comparison to how bad the bad decisions were, right? So in terms of magnitude, this is much less than good decisions. The other thing that you'll also note is that the same thing happens with importance as well. Somehow the good decisions were really important and the bad decisions were not as important. So that's interesting. So already starts to hint or highlight some kind of a retrospective bias. When you look back, when you think about these decisions, you almost always pay more importance to good decisions and over bad decisions, some kind of survival value, right? The next question that you might have seen there is what made good decisions good? And this is again from the last survey in class. Overwhelmingly, the majority said that good decisions were good because the outcomes were good. Bad decisions were bad because the outcomes were bad. That makes a lot of sense. And of course, they also highlight some of the other points, like, for example, that good decisions were good because it opened up more choices for you, and it expanded the future options for you, going forward. Whereas bad decisions narrowed down the options that you had access to. It was unexpected. Let's say you bought a lottery ticket and you won the lottery, right? So that was super unexpected. So therefore, it became a really good decision to buy a lottery. But another way to think about this is, what would you do if you didn't know the outcome? And most of the times you don't know the outcome. You bought a ticket and you won the lottery. Well, it became a good decision post hoc, but what would make it a good decision to begin with? Is the question that was troubling a lot of people in the 17th and 18th century. We already looked at outcome. So here we're now moving to the second phase of the talk, where we're talking about a more formal approach to how we make decisions, right? So good outcomes are fantastic, but if you don't know the outcome, let's say you're betting on a lottery, then you at least want to know that there is a good probability that you will win the lottery, right? So that's one thing that you're looking for, that there's a high chance that you will win the lottery. And you want that sort of certainty, like, which is always going to be low when it comes to a lottery, but you want some kind of certainty. So that definitely goes into what makes a good decision, right? If there's a high chance of something happening that is good, that's a good decision. You also want to know whether the lottery is going to give you high money, right? If the lottery is for a low amount of money, then you're again not going to make that decision to buy the lottery ticket. So a couple of things that you might also want to factor in before you make the decision might be in the realms of probability and value. So you want high probability or high value, of, best option would be to have both probability and value as a very high value, right? At a very high number. And Blaise Pascal and Pierre Fermat, like they in the 17th century, they were discussing how one should go about playing games, and they were looking at probabilities and how much reward people could win. And in a series of letters that they were exchanging with each other, came up with the idea of the product of probability and value, which is also sometimes referred to as expected value, as a way of calculating and mathematically determining whether a decision would be good or not. If it's a high number, then it probably is a good decision. One way of thinking about it in like very deterministic terms is, from this example. So for example, if you're looking at this question, somebody's posing this question to you, are you willing to pay 250 rupees? For what? this is a lottery again. If you get a 6-6 combo when I throw the two dice, right? That is, both have to land a 6. So this one's a 6, that one's a 6. So if I get a 6-6 combo, then I can win 3,600 rupees. So this is what I'm telling you guys today. And are you willing to pay 250 rupees to enter into this bet? And if you were those guys that I just talked about, you would do cold computation, right? You would just say, oh, the chance of getting a 6 is 1 by 6, right? There are 6 faces. Chance of getting a 6 is again 1 by 6 in the other dice. Chance of getting a 6 in both is 1 by 6 times 1 by 6, so that is 1 by 36. And the value that I get at the end of it is 3,600, right? So 1 by 36 is the probability of getting 3,600. So I'm multiplying the probability times the value, and I'm adding to it the other option that will occur. That is, any other option that happens to be the case, like 5-6 or 4-6 or 4-4, 1-1. All the 35 out of 36 options are going to fetch me a 0, right? So if I open it up like this, 1 by 36 times 3,600 plus this 35 by 36 times 0, this part just goes away, disappears, and here you get 100, right? So that means the expected value of this gamble based on those calculations that we just talked about is just rupees 100. Defined in that way, it is definitely a poor gamble to make, right? So would you have paid 250? You might have, but that's not a good decision, is all I'm saying, based on this expected value calculation. Here's another more intuitive example. So we've been talking about value, but a lot of times value only makes sense from the context of us, like from our perspective, right? If you are a person who likes barbecue, then barbecue has a high value for you. If I'm a person who doesn't like it, then it doesn't have high value for me. So let's just run with this example for now, that we all like barbecue, right? And we all want to barbecue in the sun. So we're thinking about dinner for today, in the evening, and let's assume it's a nice cool evening wherever you are, and it's still worth barbecuing outside, right? But there's a 50-50 chance of it being a nice sunny evening versus a 50% chance of it being an overcast, rainy evening. So how would you make the right decision in this case? So here's a table that I've made for you guys. It's a very contrived table. All I'm saying here, if you focus on where the arrow is right now, is that on a sunny evening, barbecue holds 100 points in terms of value, right? Now I'm going back from currency, which might mean the same for all of us, to a value that is very personalized to each one of you. But in this case, I'm defining it as 100 for all of us, right? So 100 units of value for barbecue on a sunny day, whereas if it's a rainy day, you don't want to be outside getting drenched, so its value goes down to 0, right? And for an indoor meal on a sunny day, it's just 30 points compared to 100 for barbecue. But on a rainy day, it goes up to 50 points. Because if it's rainy, you're inside, it's probably the better thing to do. You don't want to be outside getting drenched. Now, again, you can enter into the same sort of calculation, 100 times 0.5, value times probability, and value times probability. Add them all up, you will get this. This is basically just from here. And for the meal, you'll get 30 times 0.5 and 50 times 0.5, which ends up being 40. So irrespective of what the weather is, you get a higher value at the end of the day or higher expected utility for barbecue over the indoor meal. So it makes sense that you decide to go with barbecue nevertheless, right? You give it down with the weather. You want to go ahead and barbecue. In the chance of it raining, you'll take the chance and get wet, right? That's how you should be behaving in these conditions. So all of that I've talked about so far is normative. Normative here meaning this is how you should be calculating and making decisions. But of course, it's another point that we may or may not be doing all of this in this way, right? I'm not talking about your values being different from mine, but about how we go about making these calculations, which we don't, of course, make on a daily basis in a conscious way, right? we don't remember or can't come up with circumstances where we can actually remember having made these calculations. And all of this looks a little Greek and Latin when you actually put it on a slide and try and make it so explicit. But at least mathematically speaking, this is how one should be calculating. Even if you assign these values to these meals in this particular way, this is how you should be making decisions. But do you make decisions in this way? That's the question. So in the next set of slides, we're going to discover a set of anomalies. We're going to go through some examples where you will also answer some polls. So this is actually the time for poll number 2. So please help put poll number 2 in the chat box. And we will discover one such anomaly in the next slide. And this is typically referred to as the Allais paradox, named after Maurice Allais. And he came up with this very interesting example, which is also very contrived, but helps to clarify the sort of decisions that we make, right? So there are 2 questions in this poll. Question 1 asks whether you want to go for option A or B. So option A says you can get $4,000. Let's assume this is US dollars. $4,000 with a probability of 0.8, right? Or do you just want to walk away with $3,000 for sure? So there is a probability associated here. There's some amount of risk. There's 80% chance you'll get this. There's 20% chance you might get nothing. Whereas here, you have $3,000 that you can get for sure. So which option do you want? Choose that. That's your result. That's your answer. There's another question that follows that. Here things are changed up a little bit. You can see that the probability has become 0.2 probability, that is 20% chance of getting 4,000 versus 25% chance of getting $3,000. So the question is, which one do you want to choose out of these 2 options? So go ahead and play this really quickly, because I'm going to zoom out and open the survey results for you guys to take a look at. Are you guys responding? Okay, so wonderful. So there are 10 responses now. So I'm going to stop now. Oh, 15. Okay, so I'll give you like 5 seconds more. Okay, so here's the response, right? You can see it. Can you guys see it? Just confirm once that you can see it.
Yes, we can see.
Okay, wonderful. So when I said, great. So a lot of them wanted B, right? Okay, that's what we want. So here, 3,000 for sure is exactly what a lot of people want. So 14 of you out of the 18 wanted the $3,000 for sure, right? You don't want any risk associated with this large amount of money, right? And very few of you actually went for the risky bet in this case, right? Now let's see what happened in the other case. So here it became a bang 50-50, right? This is also pretty interesting. So this gamble was treated in a slightly different way as compared to this gamble. And I'll tell you why this is interesting, because when you actually do the math, in this case, for example, that is, let's say you chose the, just ignore the first line for now, just look at this line that I'm pointing at. That is the utility or the value that it holds to you, that the $3,000 for sure holds over the 0.8 times $4,000 holds, is the first equation, right? So somehow this was valued more than this by a majority of you. Whereas in the other one, these were almost equal, right? So I can edit this out because there's a slightly different result this time from you guys. So let's make it equal. So 0.2 times 4,000 is almost equal to 0.25 times 3,000, right? Now you can get from here to here just by multiplying by 4, right? It's exactly the same. So that is, you do 0.2 times 4, it becomes 0.8 probability for 4,000, which is exactly this. And 0.25 times 4 will make it 1 into 3,000, which is exactly this. So now you can already see that there is a huge amount of asymmetry. what was equal here for a lot of you was not equal here for you guys, right? So somehow making 1 and 2 incompatible, as per what we have been saying mathematically, rationally speaking, so far. And this is referred to as the Allais paradox. And this guy actually came up and did lots of other things for which he went on to win the Nobel Prize for something else altogether. So if you're curious about Maurice Allais, this is a good website to go check out. But all this and other such irrationalities, right? When it comes to how we actually make decisions, sort of led to or gave way to what we today refer to as prospect theory. So let me briefly describe who these people are. This is Amos Tversky and this is Daniel Kahneman. And both of them were Israeli psychologists. And in fact, there is a fantastic book about them, about their friendship, and about how they actually did science together, which is called The Undoing Project by Michael Lewis. He's also famous, this guy, the author is famous for other books like The Moneyball, which became a movie later on, so on and so forth. So he's very good at writing about science and scientists, and this is one of the best books that he's ever written. And the book actually explores how these two scientists got together, did their work so well that you'll actually take away a lot of science that they came up with along the way as well. And they were very, very different personalities, but how they gelled together is actually what makes it all the more interesting. But what did they do overall was they came up with the idea of what is today called prospect theory, and they called it that back then as well. And they won the Nobel Prize for it in '99, I think. I'm not exactly sure. Kahneman did, but Tversky was not alive at the time, so he couldn't get the Nobel Prize. But they essentially got it for prospect theory, which they together came up with. But what was prospect theory all about? I'm going to give you a brief glimpse of that. But it is not a normative account, which means to say this is not how you should be deciding. This is what we've been talking about so far. But prospect theory is actually a descriptive framework. Descriptive meaning you make people do decisions in different conditions, like the one that you just experienced, and highlight all the things that are not according to the normative theory or how you should be doing things. Why are things different? And try to accommodate that under a framework. And that is prospect theory. One thing that they highlighted, and this actually comes to poll number 3. So if you can post poll number 3, then you can answer that, and I'll talk about what's there in the next slide right after that. So they came up with prospect theory. I should have said this like right before the slide, but anyway, sorry for delaying that. Let's go to the slide and see if people are taking the poll. Okay. So poll 3 is posted. Okay. So the responses are trickling in. All right, good. So go ahead and answer this. Let me see what you guys do. So it's a simple gamble, right? The situation goes as follows. That is, I'll toss a coin. If it lands heads, you win some amount of money. If it lands tails, you lose some amount of money. Are you willing to take the gamble? That's the question. If you say yes, then go for A. If you say no, go for B. Right? Super simple. Now we're going to check again from the lens of our expected utility theory and the normative decision framework, so on and so forth. So not to belabor this further, so let's go on and look at what's going on. So for the first question, when I toss a coin, you get 100 or you lose 100. A lot of you are saying no, right? So a lot of you don't want to take this gamble. So even though you could win 100 or lose 100, so it's the same amount of money, nobody wants to take the risk because there's a 50% chance that you lose 100 rupees, right? And that stinks, right? More than what would be the case if you were to get 100 and felt happy. Now let's see what happens if I make it 200. So remember this 72, 28, right? So let's go down and see what happens if it's 200 is to 100. So then it's sort of becoming more even, right? Now a lot of people are saying yes, actually. So it's turned scales now. Now a lot of people are saying yes. A few of you are still saying no, because even 200 is not enough to offset a loss of 100 rupees, right? You don't want to lose that 100 really badly, right? Like these people over here. So now let's see what happens. Let's go further. So now I'm promising them 300 and you can still lose 100, same chance, 50-50. But now it's very few, like two of you, in fact, who are still opposed to this bet, right? You still don't want to lose that 100 that you hold on to, that you're holding on to dearly. So that's really, in a sense, what's happening, right? So if you were to go by expected value or expect whatever, like the normative models that we were talking about, these two numbers are exactly the same. The probability of winning this and losing this should be equivalent, right? But of course, people want more gain to compensate for equivalent losses, right? They are not rational in that sense. And that's really what these guys said. One of the things that these guys said, I'm not going to talk about all the things that they said, that the pain from loss is much more than the pleasure that you derive from the gain, right? Or in fact, almost on average, 2 times more. So that's why you see things turning scales, changing the balance when you have twice as much money to gain as compared to losses. So it really stinks to lose money. There are also lots of other things that went into prospect theory, but in the interest of time, I'm not going to talk about all that. But the Undoing Project or Daniel Kahneman's book that was launched a couple of years ago, Thinking Fast and Slow, are fantastic introductions for this theory. But I'll now move on to something even more interesting, right? And I'll talk about Richard Thaler a little bit, and I'll talk about his book called Misbehaving, which he published a few years ago, and where he also documents what is called the endowment effect. Again, talks about another thing that we all do that cannot be explained by just rational calculations based on probabilities and values, right? And the reason why this is called misbehaving is very interesting. So I'll say that in 30 seconds. So until the time of Kahneman and Tversky and Thaler actually worked with Kahneman and Tversky as well. So until that time, for the longest period, economists assumed that humans were extremely rational, right? That we will calculate well, we will make the right calculations, and we will act according to that. So in fact, we were treated as robotic rational agents, cold computing agents, right? Like Spock. But of course, it turns out that we are not at all that. We make all kinds of mistakes. When we make these calculations, we are not at all optimal from the mathematical point of view. And you've already seen some examples now. We'll see a few more down the line, right? So he documents a bunch of different things that he found during his term as to how we violate rational explanation. And that's why he calls it misbehaving, because we're clearly not behaving as per old rational calculations. And he went on to win the Nobel Prize in 2017, I think. So behavioral economics is the branch of economics that deviates away from the cold rational computations and treats people for what they are. Like, this is a merger of psychology and economics in some sense, to really understand people for what they do and how they do it. And here's one interesting experiment that he did. He took these college campus mugs. So imagine, this is very popular in the US, but it might also be the case in many institutes in India now, where you will get these mugs with college emblem or the logo or something, right? So you'll say, let's say IITK or IISER Trivandrum or something like that on the mug. So the exact same mugs, right? Like this one and this one are the same ones. He just distributed, he called 20 people to a room. He gave 10 of them the mugs, identical mugs, and 10 others didn't get the mugs, right? And then he asked them, the 10 others, to ask for the mug because they really wanted it. And the 10 who already had it by luck could sell it, right? And the mugs cost $5 everywhere. Like that was the cost of the mug anyway. So when the mug was yours and you had to sell it, the average selling price was 7.12. That is, they all drove a hard bargain and didn't want to sell it for less than 7.12. Right? Whereas those who didn't have the mug and were asking for it, they're always asking for a lower number. And they always ask for something like close to $3. So which he then went on to call the endowment effect. That is, when something becomes yours, you attach additional value to it, and that additional value is what is reflected in this price that you want for selling it. The same happens to houses as well, right? Like your house, when you want to sell it, you will always inflate the price.
There is a question from an audience. Can we interrupt in between?
Sure, yeah.
Just a brief question. Were the participants aware of the actual price of the mugs?
Oh, yeah, they were aware. I mean, they all knew this was from the university, so they knew the price of the mug. That's why they could price it, close to the price, but higher than that.
Right. Thank you.
Yeah. So that's another very strong, robust illustration of the endowment effect. And people criticize this for using college mugs. Then they went on to show this in housing and in more real-world situations. So it is pretty robust. It scales, across different categories and values. Is there another question?
Yes.
Yeah, sure. I can't hear you.
Hi, Talika, we cannot hear you properly. Can you write the question instead?
Okay, so as we wait for the question, I'm just going to go down because I have a feeling I'm running late. So I'm going to run through like a few slides, and then we can take the question once it's appeared on chat. Okay, so here's another thing that these guys found out, right? That there is also something called the context that affects how you think about the situation. So if the next poll can be posted, I think it is poll number 4, right?
Yes.
Yes.
Okay. Yeah, please post poll number 4. And that's essentially what's written here, which is that you're now in charge of a program, like you're a program officer, and you are told that there is this, I don't know what, fertilizer or something, that if you adopt that program, 200 people will be saved. Or if you adopt the other program, program B, then there is a 1/3 probability that 600 people will be saved. But there's a two-third probability that no one will be saved. That's the first one. And then there's a second one that's slightly different, which says that if you, there's a comparison between programs C and D. In C, if you adopt C, then 400 people will die. If you adopt D, then there's a 1/3 probability that nobody will die and a 2/3 probability that 600 people will die. So you have to choose between C and D for this question, and you have to choose between A and B for this question. Now let's go quickly check out what people are saying. Right. Close all the overviews. Hey, there are 5 responses. I'll wait for another 30 seconds, so go ahead and answer. So we'll do this. I have a feeling we're running slow, so let's stop now and let's see. Okay, so in the first one, a lot of you wanted to adopt program A, although the difference is narrowing. Now it's becoming cruel. Okay, so 200 people will be saved. Okay, now it's back to A. All right, so we'll go with A for first one. And what happened to the second one? This one. I don't know if this is, yeah, C and D. Okay, so this looks different. Okay, so in the first one, it is A. In the second one, most of you have opted for D, right? So, so that's basically the framing effect right there. So if I frame it in a way, if I put a positive frame of reference for you guys by saying, oh, 200 people will be saved, then a lot of people want to choose that, right? But if I put a negative spin on it by saying 400 people will die, although it's the exact same thing, out of 600, 400 will die, meaning 200 will be saved, then people choose the other option, right? So that's really what framing effect is all about in some sense. So good, so that held true again. So the other point, the point that I'm trying to make here is that there are plenty of reasons why people will make decisions that are completely inconsistent with their own ways of calculating things, right? If you really care about people being saved with surety, then you would have gone with A and C, right? If you took some risk, you would have gone with B and D in both cases because they are completely equivalent options. But people always fall for certainty when it comes to saving and or gains, and they will take up the more risky option when it comes to losses. That's also part of prospect theory, but it's also referred to as the framing effect. And same with this, so I'll actually skip this slide, but it only says that you can always advertise as saying that this spam blocker only blocks 4% spam, or you can actually put it the other way, which says, oh, it is 96% spam free, right? And people actually fall for how you put it in context, put it in that particular context. Okay, so with that, we'll move to the next topic, which is about decision making when you have plenty of choices. So we've been talking about a couple of choices so far, but we'll now increase the choice range because that's how life is today. You go to a supermarket, and even if you have to buy just a toothpaste, you have to actually reckon with 6 or 7 or 8 odd brands and multiple flavors within those brands, right? And it's a hard job. It's not easy at all. And if I asked you, and in fact, this was part of the question in the what makes a good decision poll, what makes a good decision is actually the fact that you have many choices, right? That's what some of you might have said and might actually think. And some of you might think that, oh, it opens up many more options. But in several examples that people have actually done and systematically understood how decision making is impacted by choice, there's almost always something else going on. In this first study, for example, by this group in 2000, they set up 4 jam bottles in a stall in front of a supermarket, right? And once every 2 hours, they would shift to showing them a larger sample. So sometimes it would just be 4 bottles. Sometimes it would be, I don't know how many, like maybe 12 bottles, right? So maybe it was 6 and 24. So that was the actual size used in this study. And they switched this display every hour. And what they found was actually very interesting. So if you had more jam bottles, then people actually stopped to sample them much more than they did when there were fewer bottles. So this is very consistent, right? You would want to stop if there are lots of bottles, very cool looking, colorful, variety of jams, then you actually want to stop and check out what's happening and sample it. And that happened more when there were more bottles. But then when you actually looked at purchases, it was much lower when there were more options. So that's set off alarm bells that maybe something's going on when there are too many choices. Too many choices is probably difficult to compare them, probably too difficult to make a decision. Sometimes you reach some kind of decision paralysis where you don't know what to decide, so you postpone the decision. Sometimes you don't know how to compare because they may not have equivalent attributes. And all those things happen, right? So that has been further explored, understood better. But again, in the interest of time, I won't talk about that more, but you can always refer to more materials on that. But I'll talk about another really cool example that talks not about 2 options, but 3 options now, right? So, and this is referred to as the decoy effect. This is again playing on the fact that if you have more than 2 options, and you have to make a comparison, you have some default ways of making those comparisons, and people have figured that out and they take advantage of that. And this is what I'm going to talk to you about now. So if I were to ask you that, do you want this 22-inch TV that costs $150 or this 32-inch TV that it costs about $300? So now it's very hard to decide, right? If you have less money, you'll go for this. If you really care about size and you don't have, I mean, you have a lot of money, you might go for this. But these two are different in two attributes. It's different in screen size, it's different in price. It's very hard to compare them. So you'll go based on what you think is good for you, right? But here's what shopkeepers will always do, or advertisements will always do. They'll always plant a decoy. They'll always plant a decoy to push you towards the one that they want you to buy. In this case, this decoy is actually smaller in screen size compared to this TV, right? Clearly the worst option compared to this. It's also more expensive than this TV, right? It's smaller, it's also more expensive. And then, therefore, it'll make you think, now this helps you compare these two in some sense, right? You think that, oh, this is smaller than this, but also more expensive. That makes this a good bargain. So you might end up buying this. So they might have ended up nudging you towards this just by planting a decoy. Now, if you can post poll number 5, let's play around with one such in the poll as well. So I'm going to zoom out, go back, check the poll, and see what's happening in poll number 5. So what poll number 5 says is that, let's say you're subscribing for your favorite magazine, right? In this case, let's say it's The Economist, because I'm using this. This is the exact study that was done several years ago. The subscription for The Economist, and you have the print-only subscription for 125 rupees a month. You have print plus digital for 125 rupees a month, and digital only for 59 rupees a month. So which option do you want to choose? That's the question. 10 of you have responded. That's fantastic. 15. Oh, great. Okay, so I'm going to stop and go check the results now. So what happened? So print plus digital, 125 a month, right? Exactly. That's what you should do because that's exactly what they want you to do, right? Okay. So so digital only is competing, but anyway. So we'll come back. I'm going to stop the poll now, but let's go back to this because this is exactly what these guys did several years ago, right? So before they put the decoy option, and you might have guessed what the decoy was. So before the decoy came into play, they only had the digital and the print plus digital option, right? And so the digital was $59 in this case. So I changed it into rupees for you, but and the print plus digital was 125. And so a lot of people went just for the digital because it's like pretty low compared to this, right? And it makes sense to go for the digital in this case if you have a low budget. And so this was the total revenue that they were making based on this, right? So many people went for this, so many went for this. This is how much money they made. Then they got an economist into the mix. He suggested putting in a decoy option, which was the print-only option for $125, right? You might have thought this is a crazy question, right? Because print plus digital is almost exactly the same as print. Why the hell did they do that? That's because this was pure and simply a decoy, right? And when you put that, it makes it easy for you to compare this. And now you've been nudged away from the digital only option, and you've fallen prey to the print plus digital option, right? It's not the wrong decision, but that's what they want you to make. That's the difference, right? And of course, the revenue went up, so they were really happy with whatever they did. So what you should be careful about, right? Like when you're making choices, when there are multiple options available, there is almost always a decoy that is there to nudge you towards the right option. And that's what they want you to do because that's what you will normally do. Okay, so that's all the different things that I wanted to talk about in terms of how we deviate from the way we should be making decisions, right? So now I'll take a turn and I'll jump into a little bit of neuroscience and say, how does the brain do all of this? How does the brain help you make decisions? And I won't really touch on what leads to biases, but at least set the ground for how we make decisions. But before that, I wanted to do a very, very super brief introduction to the neuroscience field itself. Like, why do we need a brain? And I'll start with my favorite slide, which is when Daniel Woodward gave a talk several years ago on TED Talk, and he said this, and I quote this, and he himself quoted this based on someone else's words from several years ago. But this is something that struck me back then, and I've held this pretty close to me like after that, and it's becoming more and more clear over the years that this is really what it is there to help us with. And that is this, right? Like, we have the brain for one reason and one reason only, and that is actually to produce adaptable and complex movements. And therefore, he goes on to say that it's important for you to remember that when you're studying cognition or memory or sensory processing, that you're doing that because, or the brain is doing that because there is a reason. At the end of the day, you really want to be able to make the right action or make the right decision to make the right action, right? So at the end of the day, the brain is there for that reason alone. You need to take all the inputs that you get and make the right action or make the right decision to make the right action. And here's a striking example that he provides, right? Sea anemones, these are like, brilliantly colored deep sea creatures. And when they're young, they're larvae, they move around a lot, and they have a very rudimentary brain, which is a bunch of neurons connected to each other like a ganglion. But once they mature, they metamorphose, and they go and stick to rocks, like it is in this case. Like, all these are very colorful sea animals that have attached themselves to the rock. So once they stop moving, the first thing that they do after attaching themselves is actually to chew and digest and consume their own brains, right? They don't need the ganglion anymore. That's very striking, but that's one striking example of why you might need brain. And that sort of puts in context a lot of things that we might be looking at later on. And it is a complex organ, right? At least for the humans. In the humans, there are about 86 billion neurons and 10 raised to the power 15 connections between these neurons. So it makes for a super complex structure. We don't have the time for it. So all I'll touch upon is, let's say this is the human brain. The signals from the eye go back to some parts of the brain, right? And that's usually referred to as the visual cortex. And there is a lot of specialization even there. You might have heard talks by Arjun and others that there are regions that help you with very specific functions when it relates to vision. Similarly, you also have regions of the brain. For example, if you're looking top down at the center over here, you have a strip of the brain where, for example, all your movements are mapped. So neurons here are responsible for your hand movement, neurons here are responsible for your mouth movement, so on and so forth, or your tongue, so on and so forth. And likewise for your sensations. So the blue strip at the back is for sensations, and the red strip at the front, or the brown strip, is for movements. All this is to say that there is at least some amount of functional specialization that these neurons are carrying out in these different brain regions. But how do you find that out? You can actually put tiny tiny wires, really go close to these neurons. So I'm actually showing you a cut where there are neurons at different layers, and I'm using this little wire here to go very close to it and measure these electrical currents, because that's how these neurons communicate. From one neuron to the other, they actually transmit very weak voltages or weak currents that you can pick up by putting these wires very close to it and short circuiting them. So you can also imagine that you have this wire very close to this neuron, and you're measuring this, and you see that these neurons are communicating through these very interesting looking waveforms, which are typically referred to as neuronal spikes, right? And that's how you know what that neuron is up to. If, let's say, following a particular stimulus, that neuron spikes a lot because it cares about it, whereas it doesn't do anything or spikes at a very low basal amount at other times. So when you look at a plot like this, you'll immediately realize that we're talking about a neuron that you're listening to, and that neuron is spiking because it cares about a particular activity and spiking less when it doesn't care. And in fact, you can also hijack this mechanism. You can, instead of recording the signal, you can actually transmit some electrical current back into this mix. And you can sort of activate this neuron as if the neuron before this was activating it. And people did this experiment long ago in oops. Can you guys hear the what do you call it, the audio of the video?
No.
It's paused,
Okay.
so we can't hear it. Can you run? No, audio is...
No? Okay, that's fine. I mean, I'm going to just take it to a particular place and pause it here. So I'll just tell you this very quickly because we're also running short of time, that this is an old experiment that was carried out in the 50s by Olds and Miller. They had a rat in this enclosure. They provided it access to a lever. When it pressed on the lever, there was a wire that was going into the brain, to a region in the brain, which when stimulated, by stimulation I mean that by stimulation I mean pass current into this and hijack the activity of this neuron, right? So it's now being controlled by us. And when you do that to a particular brain region, this rat actually goes crazy and keeps pressing that lever again and again and again. It's like taking some kind of a drug that puts you on a high, right? And you want to do that again and again and again. And this is actually what they showed with electrical discharges into the brain. But it suffices to say for today, for the talk, that you can put a wire into the brain very close to these neurons and you can record activity. You can also hijack activity back by controlling it and determining what that neuron is up to. That's my intro to neuroscience. Now I'll switch to topic 6, which is, now how do we know? Like, we learned about how we make decisions, we compute value, we need probabilities, we multiply them, that's how we make decisions, but then that doesn't hold in several conditions. Now I'm coming to, where in the brain is all this happening? What do we know so far? The first of those experiments was actually carried out in 1999 by Platt and Glimcher, and this was in a rhesus macaque. Rhesus macaques are the most commonly found monkeys in the northern parts of India. But in the south, you might find their cousins, which are usually the bonnet macaques. But they have very similar brain structure. So this is the brain of a rhesus macaque. And this is the front, the back. This is the central sulcus. And this is a region just behind the central sulcus called the LIP. It stands for lateral intraparietal area. It's a mouthful, but just remember lip, right? So this area becomes very important because it's receiving signals from all visual areas. It's also sending signals to all the motor areas that I talked about. So it's sort of sitting somewhere in between. And it's also getting some reward-related signals, which I don't talk about here. So these people thought that this might be a really good area to check how things change, or how are these neurons firing, depending on the value of the stimulus, right? So value was not known at this time. We knew some brain regions were related to reward. We knew some brain regions were related to vision, some were related to movement, which is what I showed you so far. But we didn't know anything about decisions. So the first time they were actually in this brain region, just like I showed you a few slides ago, and lo and behold, and this is the experiment they did actually. So they would flash 2 targets. One of them would be a high reward target, and it was also associated with some probability. And they would check how often, and they would ask the monkey to go to that target, like, forcefully, and ask the monkeys to forcefully go to the other target sometimes. So of course, the high value target would be more interesting to them. The low value target is less interesting to them. And what they're actually computing, or what they're trying to assess, is that value times the probability, whether that's being reflected. Of course, it'll reflect in the monkey's behavior, but is it also being reflected in the brain? Right? And they actually found it. So that was the first demonstration of value and probabilities being mixed or multiplexed or multiplied in a specific brain region. So if there was a large gain expected, there is a large reward with a high probability, then these neurons were more active. So how do you know? Because they are firing a lot more, right? Like this is the plot that I talked about earlier, where all these little tiny dots are actually spikes or neuronal spikes that I showed you earlier in that funny shape. That tells you that the neuron is excited, it's very active, it's exciting the neurons after it. In fact, you can see here, there is the gain ratio or the, there was some kind of noise. Say a question.
No, it's like people rejoining the meet. Sorry, ignore it.
Okay, yeah. So, all right. So basically what we were talking about was that for the first time, they actually discovered a neurons in this particular region called the LIP, where they were firing in accordance to the value of the option that they were choosing, right? Sort of indicating that we did have such neurons, that we're computing the overall value based on the probabilities and the utilities. Later on, people went on to show that in fact there were specific brain regions that were computing value irrespective of the situation. It could be a social situation, for example, if people are asking you about, holidaying with your friends, that could have a lot of value to you, right? Or if they're asking you about a lottery or some kind of monetary gain, that has some kind of value to you. But in fact, when they put these together, you could see that there were certain brain regions that were active irrespective of the actual situation, somewhat similar to how you would expect some kind of universality for value, right? If you were to expect that there is some universal value to all of this that is helping you compare them in some ways, then you would expect that to be the case, that there are some neurons in the brain that are able to compute value irrespective of the context, which is what they were able to show. But of course, all of these paradigms that we've been studying so far are based on some kind of an economic paradigm, right? That is, you provide options, you ask people to compare, so on and so forth. But there has been a lot of argument back and forth between economists and biologists and others like ethologists and behavioral ecologists who say that the brain has developed not brain is developed in conditions where you've not really had the chance to compare options like that, like we do today, right? And therefore, maybe we should look at problems like foraging or fighting or fleeing or reproduction. Like those are actually the more natural circumstances. Like for example, that's the situation that early man has been for several years, right? Like the last 90,000 years of our existence, 90,000 years of our existence on the planet. It's only in the last 10 that we've actually lived a settled life. But before that, we were foraging, we were fighting, we were fleeing, and we still continue to reproduce, right? But we might be using some of these circuits for other related purposes even now. So let's take, for example, foraging. Like this is the act of actually going about getting food from different places to satisfy your hunger, to satisfy your metabolic needs. And this is one such activity where you go from one place to another, you collect food and you decide whether to go to the next place, so on and so forth. But you're never really comparing two options simultaneously. You're making sequential decisions of sort. And in fact, although it sounds like a super simple activity, remembering where to go, choosing the right fruits is actually pretty complex. You have to know where these fruits are. You have to know by color, based on the color, that they are ripe or not, nutritious or not, poisonous or not, so on and so forth. So it's actually pretty taxing. So in fact, when people have looked at this, this is one of the most compelling hypotheses for the development of brain size. That is, decisions that you make about food, as they become more complex, have led to increasing size, at least in primates. And so what we've and others have done is we've reduced these games or reduced these activities to something that is more tractable, something that is virtual in the lab. And all that you have to do in these examples is that you are out and about to get fruits, but you're also moving about and spending energy, and you have to decide what is the optimal trade-off. You continue getting strawberries in a particular bush, Or at some point you decide that, oh, I'm not getting as much. I might be better off by traveling to the next patch, right? Like that's the decision you have to make. So suddenly now we're talking about foraging. We're talking about decisions made in the context of foraging. But again, it all boils down to similar calculations. What is the current value? How is the value decreasing over time? When does the value of leaving the patch increase above the value of staying in the patch? And when do you make that decision, right? And we and others have also recorded from different brain regions to understand that regions like the ACC, the anterior cingulate cortex, is actually responsible for, or neurons in this cortical region is actually responding to such comparisons. But where do we go from here? So this is actually the last segment of the talk. So what I've said so far is that this is how you should be making decisions, but these are all the ways in which we don't make decisions the right way in these different contexts. Then we talked about a little bit of neuroscience, and then we talked about where in the brain these computations are happening. And then I talked about a lot of criticism in terms of how we've only looked at it from the economics perspective, but we actually also have to look at it from the biological perspective. That this is how the brain evolved to make decisions in a certain context. So maybe those are the contexts in which you have to engage animals and humans to really understand how the brain enables these decisions. Because that might be the best bet to understand how we make decisions in these conditions. But why are we after all this, right? Like, why are we really trying to understand the decisions that we make? It is because at least we believe that your decisions and the actions that you make or your behavior is also intuitively changed by conditions like anxiety or depression or several other mental health conditions, as well as regular normal conditions like stress or fatigue, right? These are prevalent but highly treatable conditions, but they do affect the way we make decisions, the way we go about activities on a daily basis. And that is what we're interested in the lab here. So we make models of decision making, we make humans and animals play those games, and we try to record from brain regions of interest to understand how they are encoding this activity. And we also sometimes stimulate to understand whether those brain regions are really involved in that activity, and build models to understand whether that can tell us anything more about that particular condition that we are interested in understanding. So can anxiety change our decisions in a certain way? And therefore, can decisions, the change in decisions be a very sensitive marker for conditions like anxiety? In fact, we've had some success with this sort of approach, where we've had people wearing an EEG device which picks up some brain signals and playing these games that I talked about, like a foraging game. And we are able to use that along with some algorithms to predict how anxious someone is, even just based on the decisions that they make and their brainwave activity. And that is where I'll end today's talk, and I'll open the floor for questions. I'll also put on this acknowledgement slides for all the grant agencies that have made this possible. And I know this is like a very introductory talk, but if you're really interested in all of this, then there are plenty of very awesome talks by people like Paul Glimcher, Michael Platt, and I've also picked a lot of material from the neuroeconomics textbook that you can refer to, which is also something that I refer to for this course that I teach in the spring semester, called Decision Making and the Brain. So that's the exact same title. And yeah, and I welcome more questions on this and other topics. Thank you.
Thank you, Arjun. That was really a very, very wonderful and engaging talk. We really went through a lot of topics, from really economics of decision making to the real neural correlates of that. So I'm sure audience would have some questions here.
Yeah, I know. Yes, Provit.
So, as you said, the movements were repeated in the mouse, the experiment that you showed from 1954. Are there, I mean, by hijacking the neural signal, by stimulating the neurons, has there been any such study where decisions are repeated by stimulation? I mean, I guess movement is also a decision, but an abstract decision, I mean, does not involve movement.
Yeah, I mean, I think so. That is, so for example, sometimes what happens is that you are so used to doing certain things that it becomes what is referred to as habitual, right? And let's say you're always, you wake up in the morning, you put on your clothes, you put on your helmet, and you take your scooter and go out or something like that. And you're so habituated to that 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 almost flows in a certain way, right? Like that's some kind of reinforced behavior that sort of flows in the same way at all times. That is an example of a real world example for decisions that get repeated often, and they get so reinforced that they get repeated, and it gets harder to break them the more and more reinforced they get. But what's also interesting is that there are studies in rats and maybe also some other animals, I'm not sure, where they've been able to hijack the circuit to make certain behaviors repetitive. Right? You can almost always, I mean, you can almost make some behaviors more repetitive by hijacking a certain circuit. Yeah, so that sort of thing has been done. So you can um, create a sequence of behaviors that can be reinforced, or you can create a behavior that is reinforced in a certain way that becomes habitual, and then you trigger it and the whole thing happens, something like that.
Does this involve a reward mechanism or just with stimulation?
Yeah, so that's a good point. So I mean, I think it does involve reward in most conditions, and stimulation, in fact, is a proxy for reward because you're stimulating some circuits that are triggering off or exciting these reward pathways and ending up reinforcing in some sense. And that's what happened in that rat example as well. So you're stimulating the lateral septum or some region thereabouts, and that is giving the rat such a rewarding feeling or sensation that it's ending up doing it again and again and again at the cost of, this is what I didn't say then, at the cost of not eating, not sleeping, and not interacting with conspecifics. The rat was pressing the lever until it died. So it actually, so in those experiments, it pressed like 20,000 or 10,000 times before it finally was too weak and then passed away.
Thank you.
Thanks.
So, Lisa, you had questions?
Yeah, am I audible?
Yeah.
Regarding the endowment, I mean, it's kind of a stupid question, but I was just wondering if giving more value to one's own possessions is just like a form of profit seeking.
Profit seeking. Yeah, I mean, I think here like you could distinguish it from profit seeking. For example, if it were to be just money, then you would treat it in a certain way. But there are so many other conditions in which it is not just about money, but you would still behave in the same way. So that's what I was referring to when I said that they have actually gone beyond just mug or money or some of these conditions and cut across to other conditions to show that some of these effects are there to stay. I mean, it could be partially driven by your own selfish motives, but at the end of the day, it has some value to you, right? And that's what is making you not so rational because you're not computing or incorporating those values into your calculations.
Right, thank you.
Thanks. Okay, there's a question. Another question that I found the concept of virtual foraging is a lab to study based behavior, a pretty frugal but possibly useful approach. Yeah, I mean, so we've done various versions of this. So you can create a computer game, you can create a virtual reality version of the game. You can also do live foraging. So we've put devices and we've asked people to go into a strawberry field and collect strawberries. So that's also something that we've done. But the trade-off here is that the more controlled the environment, like if you're doing this in a lab on a computer screen, then of course it is less and less like the real world experience. But it is much more controlled and you can vary exactly the parameters that you want to vary. And so you might get a better understanding of what is going on. Whereas if you do the real world experiment, it is of course real world realistic, right? But then there the problem is things are going to be very, very less, less controlled, because lots of things can change. It can be hot for one guy, less hot for the other person. Some people are thirsty, some people are hungry. It can be very, very different for different people, and therefore much more difficult to understand what is going on. But in general, the field is going towards more naturalistic real world experiments, because sometimes it is hard, just like I was criticizing some of the economic studies by saying, oh, we never evolved to solve them. So our brains may not have evolved to solve them. The same criticism applies to playing something on a computer where people might interpret it in different ways and may not really have evolved to solve those specific problems in those specific ways. And then the interpretations that you might make might be flawed, and you'll only realize it much later.
Hi, great talk. So I had a question. So it was a common theme across the slides that we are more prone to risk aversion as compared to going for gains. So if you have a decision, you would probably want to, even if there's a little bit of risk involved, many people would not want to take that risk, even if it is giving a lot of gain. So I wanted to know if what is the neural basis behind this sort of disparity between going for gain and risk aversion, and why are we more sensitive to averting risk rather than just going for it?
Right. So I think that's a really good question. So we didn't really talk about the neural basis for some of those biases that we discussed. A lot of that is still under study. And in our own lab, like a few years ago, like we published a paper on the neural basis for, or at least the mechanisms that we thought were underlying that sort of decisions, right? And there are some hypothesized mechanisms. Some people hypothesize that when you're confronted with risk that is sensed as some kind of danger in the future, and all the circuits related to, or your brain circuits related to threat and fear and anxiety, those are activated, and that sort of dampens the reward value of that option, and therefore you don't choose those options, right? And that's a good hypothesis, and that's held true in some conditions at least. And not to eliminate certain other alternative hypotheses, but it might suffice to say that that sort of thing might be underneath why the reason underneath why why you might not choose options that are associated with risk. But that said, that is the average behavior, right? Everybody is different, and you might have seen the poll as well, that some people were okay with taking the risk even at 100, right? So that's interesting. So people are very different. So there are people who also seek risk. There are also people who are averse to risk. But people who are risk averse are on average more in number, I think. So it's not as a, like, from an evolutionary perspective, it might be good to have the entire mix in the population in some sense, because you don't because you want some people at least who will take the risk and find out what's going on at some cost to themselves, right? But then they might find new territory, and then people who are risk averse can actually go take good advantage of it. But people who took the risk might have found it, but then might have perished trying to identify it. Something like that. And this has always been happening in all societies over several years. So I think there might be some kind of a balance. You might have this population, you might have this also.
Yeah, that was the point I was looking forward. So as a follow-up to that, like as you mentioned right now about a lot of circuits involving the involving fear and involving anticipation also being involved in this decision-making process of whether to take the risk or whether to just go for it. So I was thinking if it will be very wild to say that there might be a correlation between mood disorders such as anxiety and the risk aversion of a person the magnitude of risk aversion of a person, or is that just something which does not correlate at all?
Oh, that's another good question. So in fact, people have been trying to find that out for several years. I would say, I mean, there's been some good evidence in that respect. That is, you do find that people who are risk averse or people who are anxious or depressed are usually risk averse. That has been shown by studies, but there are also studies that have not been able to find very strong, robust effects to that of that nature. So yeah, so I think the answer is probably, I mean, I think it's probably true. It intuitively feels very right. So it's probably true. But there is also a lot of variation in the population. So there are variations now at two different levels. So you have how risk seeking or how risk averse someone is. That's one spectrum. But then the other bigger problem is how you define conditions like anxiety and depression.
Yeah.
So those are very complex terminologies based on a cluster of symptoms and not really how biology might partition them based on, I don't know, like something biological, right? Like it's all completely based on symptoms that we have learned over time to associate with those conditions. So yeah, so I think those are all the problems. But if we were to figure out, so for example, if risk aversion is related to a particular circuit, so you might see risk aversion across different conditions. So you might see people with schizophrenia who are also risk averse, who are anxious, who are also risk averse. So it might cut across conditions, sort of identifying some dimension that might be true, irrespective of other things that you're also suffering from.
Yeah, thank you so much.
That might probably be a better way of looking at it, actually.
Yeah. That's very insightful. Thank you.
Thanks.
Okay, if I may get my chance to ask some questions now. So you mentioned that this, a dummy is being placed to like nudge your decision towards what benefits the advertiser or the seller. So now that we are aware that this is what is being done, will that alter, we can avert their efforts to force us towards a particular decision making? Can it be like?
Yeah, I mean, I think to some extent, yes. I mean, it totally depends on, I think knowing what you want will help in many of these situations. But if you're not sure, then you'll end up comparing, right? Comparing the different options. So let's say you're going to Starbucks and there is small, medium, large, or movie theaters, right? There's always like small, medium, large popcorn balls. There's never like two options. There are always three options. And if you see the pricing, it's always nudging you towards the bigger option, right? So the medium might be almost as big as, I mean, almost as pricey as the bucket, the biggest bucket or something. So you will compare and you'll think, oh my God, like maybe I should just take the biggest one because that's definitely the cost, I mean, the value for money. Whereas let's say if only the small and the biggest were there, you'll think, I don't think I'm going to eat so much. So maybe I'll just buy the small one and go, right? So yeah, so it's tricky and it probably comes down to sticking with what you want, I guess, in those conditions. But sometimes it might be a good thing to do as well. Sometimes they might be nudging you because you should be doing something good. So there is this book written by, again, these guys like Richard Thaler and Cass Sunstein. So they wrote a book, so that came before Misbehaving, and it's actually titled Nudge. And it came in 2007 or 8 or some, like 10, 15 years ago. So that's a really nice book. So they talk about, policies that are designed to nudge you the right way. So, like how they try to put some very healthy eating style habits-based food at the front rows of some good restaurants and stuff, or like supermarkets and stuff. So they're actually nudging you because what you see is what you will use for making decisions. And if you see healthy things, then you'll probably choose one of those rather than something that is not so healthy.
Arjun, I think there was some request to write the names of the books that you have referred to so people can look them later.
Oh, sure. Yeah.
put them down.
Nudge was the book that I talked about now.
Thank you.
Misbehaving was the one I said earlier.
Okay, I think it's running. We are running very, very over time. But maybe we'll take just one last question from it.
So just something that came up from your answer right now. So the first step towards nudging is to make the decision maker compare the options, right? If they already know what they want, then there's no nudging involved.
Exactly. Yeah. So the way they usually nudge is by giving you some options that make it easy for comparison. So they'll always make it easy in some attributes. Like if they, like in that TV example, they'll give you an option that is smaller in size but more expensive. So it clearly makes it easy for a comparison there. The moment you're locked there, you're getting hijacked in some sense towards the option that they want you to take.
I was also thinking about the naming of the options. For example, in Starbucks, all the names are so exotic that you are unfamiliar, so you're bound to compare. If you already know that you want a cappuccino regular, then you're done, right?
Yeah, exactly. So yeah, that's also true. So if you make them less confident, they're going to use all the information that's available to them. Then of course you have some control over that information. All that sounds very devious, but you know, there are also good things.
Right. Thank you.
Thanks.
All right. I think with that, we can put the session to a close. So really thank you very much, Arjun, for joining us today, and thank you to all the audience who, despite the technical hiccups in between, came back. So thank you, all of you.
Yeah, thank you so much. I was really happy to be here, and send me your questions if you have any. Happy to answer them anytime.
Yeah, thanks, Arjun. We really enjoyed this session.
Yeah, me too. Thank you. Bye-bye.
All right. Thank you. Bye, everybody.